Nvidia's AI Developers Conference is underway. CEO Jensen Huang unveiling the next generation of AI chips to a packed house.
That said, though, if you're designing the perfect momentum company from scratch, Nvidia would be it.
Nvidia's new AI chip is so powerful, it's shaking up the entire tech world. It's not just pushing boundaries, it's smashing through them. Starting out by enhancing video games, Nvidia has now skyrocketed to a massive $2 trillion value in just 8 months. Their latest creation, the Hopper architecture, has everyone scrambling with waits of up to a year for these advanced AI servers. Is the control over our technology slipping away with so much power? Let us explore why this new Nvidia AI chip could not just take over the industry, but our daily lives. The rise of Nvidia's Blackwell architecture. It's interesting to note that Nvidia, originally founded in 1993 to improve video game graphics, has transformed into a significant player in the 21st century AI industry. In March 2022, Nvidia launched a new Hopper architecture system, specifically designed for data centers to enhance AI accelerators. The introduction of the Hopper architecture caused great excitement among those interested in artificial intelligence, and the demand for these products surged during the AI boom of 2023. This high demand led to long wait times for customers, who had to wait between 36 to 52 weeks for their orders of H100-based servers to be fulfilled. During the third quarter of 2023, it was reported that Nvidia sold an impressive 500,000 Hopper-based H100 accelerators. This sales volume highlights Nvidia's strong position in the AI market, significantly contributing to its massive market valuation. The complex world of mathematics, the areas of probability theory, information theory, and statistics are essential. These subjects have significantly influenced the development and design of today's AI technologies, particularly those that use transformer-based generative models. An important figure in this area is David Blackwell, the first African American to be honored by inclusion in the prestigious National Academy of Sciences. His contributions have had a lasting impact on the technology that shapes our modern landscape. By October 2023, Nvidia, a leading tech company, revealed its updated plans at an investor presentation. This was not just another corporate update, but a pivotal moment where they introduced changes to their data center roadmap. The update included the new B100 and B40 accelerators and introduced the Blackwell architecture, a shift from the previously named Hopper Next. Then, on March 18, 2024, at the Graphics Technology Conference, Nvidia officially announced the Blackwell architecture. This wasn't merely a product launch, it was a vision of the future being shared. The event drew over 11,000 people, ranging from software developers to tech industry leaders and excited shareholders. They gathered at the Pro Hockey Arena in San Jose for what was a 4-day celebration of AI innovation. The center of attention was Jensen Huang, Nvidia's CEO, who presented not just a new technology, but a transformative platform. Huang was clear in his message. Blackwell represented more than just a new chip. It was a step into a new era for computing. Nvidia is usually associated with enhancing graphic processing speeds and efficiency, but with Blackwell, they were changing the game. Previously, the Hopper architecture was considered the pinnacle of GPU technology, boasting an impressive 28 billion transistors. However, Blackwell was set to surpass this, not merely as an upgrade, but as a transformation in computing technology. The world of technology, upgrading systems can often be a complex task, but Nvidia's new transformer engine simplifies this process significantly. Consider their prototype board, which is much more than just technical jargon. It's a robust platform. Imagine a configuration featuring 2 Blackwell chips and 4 Blackwell dies, all connected to a Grace CPU through extremely fast connections. This setup is notable not just for its power, but for fitting so much technology into a very small package. Nvidia didn't stop at making powerful, compact systems. They pushed the limits further by incorporating a series of new features that challenge conventional technology limits. The centerpiece of these innovations is the 5th generation MV-Link inside the transformer engine. offering speeds twice as fast as its predecessor, Hopper. The significance of this technology extends beyond mere speed. The crucial aspect is the engine's capability to process data internally. Consider the scenario where multiple GPUs operate together. They need to exchange and synchronize large volumes of data instantly. With these ultra-fast connections and the ability to process data internally, the performance increase is not just slight, it's substantial. Officially, it's rated at 1.8 terabytes per second, but its practical performance exceeds even that impressive number, making it significantly quicker than Hopper. It excels particularly in AI training, delivering 2.5 times the performance per chip with its new FP6 format. Additionally, it introduces the FP4 format, which doubles the processing capacity for inference tasks. This is important because it leads to greater efficiency in energy use, reduction in networking demands, and better utilization of time. These enhancements are crucial for advancing generative AI technologies. The unveiling of Nvidia's latest AI supercomputer marked a significant advancement in computing power, delivering a performance that was 5 times greater than its predecessor, Hopper. Despite this remarkable achievement, Nvidia's ambition didn't halt there. Plans were already underway to develop a GPU even more powerful than the current frontrunner, aiming to set a new benchmark in the industry. This technological marvel housed 50 billion transistors, an impressive feat nearly equivalent to the entirety of Hopper. Equipped with 4 MV links, each with the capacity to transfer data at a rapid rate of 1.8 terabytes per second, the MV link switch enabled GPUs connected within the system to communicate at their peak capacity simultaneously. This development represented a major leap forward in computing, enhancing data handling speeds and efficiency across the network. New breakthroughs were just around the corner: the incredible future of humanoid robotics. The focus shifted to the evolution of the DGX system. A mere 6 years prior, the debut of the DGX-1 had been a noteworthy event, with the system boasting 170 teraflops of processing power. Fast forward to the present, and Nvidia's aspirations had soared to an astonishing 720 petaflops, teetering on the edge of achieving the exaflop, a unit of computing speed indicative of a quintillion calculations per second. This achievement positioned the latest DGX as the world's first exaflop machine contained within a single rack, a testament to Nvidia's technological prowess and engineering creativity. Central to the DGX's exceptional performance was its MV-Link spine, which alone featured a bandwidth of 130 terabytes per second, surpassing even the combined bandwidth of the entire internet. This impressive capability was achieved without resorting to expensive high-tech optics or transceivers, thereby enhancing efficiency while significantly reducing power consumption by around 20 kilowatts. As Nvidia continued to push the boundaries of what was possible in computing technology, observers might wonder about the necessity of such aggressive advancements. Were these monumental strides in computing power essential, or were they simply a demonstration of technological strength among industry giants? Regardless, it was clear that the race to develop more powerful computing systems was not slowing down, with Nvidia leading the way. At a substantial 120 kilowatts, the energy used by this rack might seem high, but even small savings in energy are important here. The cooling system is sophisticated yet straightforward, using a liquid method to keep the temperature at a comfortable 25 degrees Celsius. Air that enters at room temperature is heated to a warm 45 degrees Celsius, similar to water in a hot tub, and the system efficiently moves 2 liters of fluid every second to keep everything running smoothly and coolly. Now let's focus on a key component: the GPU. To Nvidia, this is far from just a basic part. It's central to their technology. The old, bulky GPUs are gone. Today's GPUs are complex assemblies made of 600,000 parts, and they're heavy, weighing 3,000 pounds, which is about the weight of a small car. Consider the task of training a GPT model that uses 1.8 trillion parameters. Previously, this job would have taken several months and used a massive amount of electricity, requiring 25,000 amps. But with recent technological improvements, specifically with Nvidia's Hopper technology, this task uses 8,000 GPUs and consumes 15 megawatts of power, completing the job in just 90 days. The Blackwell technology further advances this efficiency, reducing the need to just 2,000 GPUs and only 4 megawatts of power, showing significant progress in making the process more energy efficient. Blackwell is on the verge of being Nvidia's most successful product introduction, generating significant excitement as it opens up new possibilities in the field of Nvidia robotics. Nvidia is pushing boundaries by integrating technology that allows machines to interact with the physical world around them. Artificial intelligence, which has largely been limited to performing tasks within computers, is now expanding into environments where robots can operate and make decisions on their own. Imagine a warehouse where everything moves on its own. Robots and forklifts busily going about their tasks under the strict control of a central warehouse system. This system acts like a boss who sees everything, making sure each movement is safe and orderly. It even talks, managing all operations as they happen. Every robot in this place is designed to work efficiently, part of a bigger plan led by Blackwell. This is just the beginning, as robotics are set to take over more roles in the future. Let's focus on what this means for humanoid robots. Robots are becoming more common in various industries, providing a safer and more organized way to work. For example, in the automotive industry, big changes are on the horizon. Next year, Nvidia will partner with Mercedes and later with Jaguar Land Rover to bring new technology into cars. Additionally, BYD, the leading electric vehicle maker, will start using Nvidia's newest system, Thor. This technology is made for powerful transformer engines and is paving the way for robots that look and move like humans. Nvidia has also started Project Groot, an initiative aimed at significantly advancing robot learning. This project isn't just about small improvements. It's about groundbreaking developments that could change the capabilities of humanoid robots. Project Groot introduces a sophisticated base model that understands both spoken commands and past data. This model is equipped with complex algorithms that allow robots to decide on their own actions, smoothly translating human commands into robot actions. At the core of this project is Isaac Lab, backed by Nvidia. Isaac Lab uses Omniverse Isaac Sim to simulate environments where humanoid robots can practice and perfect their skills by going through various scenarios. Humanoid robots now mimic human movements with remarkable precision, enabled by Nvidia's latest technology. These advancements are made possible through complex systems that interpret human behaviors and translate them into commands for robots. Project Groot pushes this boundary even further by enabling robots to execute tasks from verbal instructions, making them increasingly human-like. These robots, driven by Project Groot, can perform a range of actions from simple gestures like giving high fives to executing complex maneuvers. At the core of this innovation are Nvidia's newly developed Jetson Thor robotics chips. These chips are specifically crafted to enhance humanoid robot performance, providing the necessary power to make these robots more lifelike and pushing them to the forefront of robotic technology. As the discussion progresses, Project Groot marks a significant advancement towards robots that operate more independently and can undertake more complex tasks. Nvidia's relentless pursuit of cutting-edge technology and software development suggests a future where humanoid robots are an integral part of our everyday lives, transforming industries and the way we interact with machines. The conversation then turns to the origins of Nvidia. The 1990s were marked by outdated technology such as blurry television screens, noisy dial-up internet connections, and bulky beige computers. During this era, computers were sufficient for simple tasks like displaying a window or text, but that was the limit unless you were involved in animation. Were all these advancements really needed? The engineers who redefined gaming. This overview suggests a future where robots perform human tasks with alarming accuracy, driven by an unceasing quest for more sophisticated and perhaps overwhelming technological advancements. Reflecting on the simplicity of the past and the complex, potentially intimidating future we are steering towards with these technologies, one must consider whether this relentless pursuit of advancement will simplify our lives or complicate them further. The early 1990s, while most people were focused on the elaborate graphics of video game consoles, three engineers from California, Jensen Huang, Chris Malachowski, and Curtis Preem, saw a different opportunity. They noticed that personal computers were not very good at handling the demands of these complex graphics. During long meetings over coffee at a local Denny's, they came up with a new idea. They realized that the central processing units inside computers worked in a straightforward way, handling tasks one at a time. This method wasn't effective for creating 3D graphics for games, which required a lot of repetitive, complex calculations. Their solution was to invent a new type of chip that could handle many calculations at once. This chip, called the GPU, would work alongside the CPU, specifically to manage graphics. This innovation was revolutionary and changed the way computers were built and used. Their idea of the GPU was not just an improvement. It transformed the computing world, affecting fields beyond gaming like science and engineering over the next 20 years. At first, however, the main goal of Nvidia, the company they started in 1993 from a condo in Fremont, California, was to improve how games were played on PCs. This market had a lot of potentials, and they were ready to tap into it. Before Jensen Huang became prominent with Nvidia, he worked as the director of coreware at LSI Logic and also as a microprocessor designer at AMD. These roles were foundational for his career. At LSI Logic, he developed skills and connections that would later prove crucial. Along with him were co-founders such as Chris Malachowski, who brought his engineering skills from his previous roles at HP and Sun Microsystems, and Curtis Preem, who had experience designing graphics chips at IBM. The transition from skilled engineers to startup founders was fraught with challenges. By 1993, they were uncertain about how to advance their new company. To help navigate these challenges, they hired a lawyer to assist with the legal formation of their business. With only $200, Huang invested in the company. This small amount not only helped to establish the company legally, but also secured for Huang a significant 20% ownership stake. However, securing additional funding to grow the company proved difficult. Venture capitalists, who provide funds to startups, typically look for teams with proven success records and convincing business strategies. The founders of Nvidia spent considerable time seeking investors who would believe in their vision. Their persistence paid off when they attracted attention from Sequoia Capital and Sutter Hill Ventures, securing an impressive $20 million in investment. Although this amount might seem substantial for a new company, it was largely influenced by Huang's previous connections with LSI Logic. Nvidia received an additional $18 million in funding, setting the stage for its future growth. At that time, choosing to invest in Nvidia was seen as a risky decision. Out of 90 companies aiming for similar achievements, only AMD and Nvidia would withstand the fierce competition. When Nvidia entered the stock market in 1999, its valuation skyrocketed to $600 million, turning the initial investment into a massive profit by multiplying it 100 times. However, let's not rush ahead in our story. At this juncture, Nvidia was just a small team of engineers, just starting out with significant funding. They spent 2 years gathering a capable team and developing their first product, the NV1, which was released in 1995. This product signaled Nvidia's official entry into the technology market. During the NV1's development, Nvidia secured an agreement with Sega to produce chips for their video game consoles. These chips were used in popular games such as Virtua Fighter and Daytona. Interestingly, the NV1 chips were also designed to work with computers, enabling users to play Sega Saturn games on their PCs, which was a novel idea in 1995. Nvidia made a bold technical choice by adopting a quadrangle-based image rendering architecture for the NV1, stepping away from traditional methods. This decision showcased Nvidia's readiness to take on technical challenges, despite potential skepticism from others in the technology sector. For their NV1 chips, Nvidia chose a method that displeased Sega. Despite Sega's complaints, Nvidia's leaders stubbornly refused to change their strategy. But what led them to prefer rendering polygons as quadratics rather than triangles? An explanation is provided in a video by Lazy Game Reviews. The idea was that using quadratics, or squares, rather than triangles, could speed up the rendering process by easing the workload on the CPU. Theoretically, this approach would mean fewer polygons to process and better depiction of rounded shapes, allowing for the creation of forms using squares where only triangles had been used before. This method seemed smart when CPU speeds and memory were relatively low, as it promised better rendering of certain shapes or models in video games. However, as technology improved and memory capabilities expanded, this method became outdated and problematic. One significant issue was the lack of support for OpenGL, a crucial graphics interface that Nvidia and SGS Thompson downplayed, even questioning its relevance for everyday users. This problem grew when DirectX and Direct3D appeared, introducing new standards that conflicted with Nvidia's initial decisions. These newer technologies highlighted the shortcomings and eventual redundancy of Nvidia's approach, illustrating a major misjudgment that would be remembered as a lesson in the technology industry. Early goals often faced tough challenges, from near bankruptcy to tech titans. Nvidia used quadratics to make game graphics better and more detailed, which wouldn't make the computer work too hard. They hoped this smart move would help them stand out in a tough market. However, as graphics tech got better, this decision started to look outdated. People who love gaming and tech saw that Nvidia's choice, though initially cool, didn't really keep up with new trends. This made other tech companies think twice about their own plans. It showed that even a smart tech choice could miss the mark if it doesn't keep up with how fast technology changes, underlining how important it is to be adaptable and think ahead in tech. When Nvidia introduced the NV1, they opted for an unconventional rendering method using quads, which initially appeared innovative, but soon revealed significant limitations. To try to fix these issues, Nvidia released a software update that made the NV1 compatible with DirectX. But this solution was far from ideal. It forced the NV1 to run DirectX in a software-only mode, disabling the card's main feature of hardware acceleration, which significantly hampered its performance. Nvidia had designed the NV1 to be a multi-purpose chip, hoping to attract customers by combining features like 3D graphics, video, and audio processing into a single unit. However, this strategy did not resonate with consumers. Huang, Nvidia's CEO, once compared the NV1 to an octopus, suggesting it was intricate and advanced, perhaps too much for the time it was released. This complexity did not translate into success, as consumers preferred more straightforward solutions focused solely on 3D graphics. Additionally, the NV1 was expensive, making it a less attractive option compared to its competitors, who offered simpler, more focused products. The broader tech industry was also evolving during this period. Microsoft had introduced DirectX, a new software that made it easier for developers to work with 3D graphics by using triangles instead of quads. This shift made DirectX popular among developers, further isolating the NV1, which was not built to work with this new standard. As a result, many games designed with DirectX did not perform well on the NV1, with some becoming entirely unplayable. This compatibility issue highlighted the NV1's shortcomings and reinforced its failure in the market. The launch of the NV2, which followed similar principles as the NV1, also did not succeed, emphasizing the market's preference for simpler and more efficient technology solutions over complex multifunctional devices. Nvidia's introduction of their new chip was a huge failure. Their business partner, Diamond Multimedia, sent back most of the 250,000 NV1 units they had originally taken, citing terrible sales and insufficient game support. This massive return pushed Nvidia to the edge of bankruptcy, resulting in the firing of half their staff, 40 out of 80 people, and left them with a massive stockpile of chips that no one wanted to buy. The financial hit was severe, costing them $10 million. While this disaster unfolded, Nvidia was also working on another project, the NV2 chip for Sega, which unfortunately used the same outdated technology. Realizing that they needed to change direction to survive, Huang, Nvidia's leader, took a decisive step. He went to the CEO of Sega and asked to end their agreement but still get paid the full amount. This was a critical move for Nvidia. Surprisingly, the CEO of Sega agreed to this request. This act of compassion from Sega was crucial for Nvidia, providing them with the necessary funds to rethink their strategy and realign with the broader trends of the tech industry. If Sega had decided to pull their funding then, it might have been the end of Nvidia. The ordeal with the NV1 chip was a hard lesson for Nvidia, but one that was vital for their survival. It taught them the importance of staying in tune with what their customers needed and where the market was heading. After this, Nvidia refocused their efforts on the personal computer market, which was growing strongly at the time. This move was well-timed and well-planned, reflecting a deep understanding of market conditions. Nvidia launched the GeForce 256 graphics card, which was more than just a successful product. It completely changed the industry. Known as the first programmable graphics card, it made the term GPU common. After the release of the GeForce 256, Nvidia took the opportunity to become a publicly traded company that same year. This move prepared them for even greater achievements. By 2000, Nvidia had secured a major contract with Microsoft to develop the graphics hardware for Microsoft's new Xbox console. This deal was not only profitable, providing Nvidia with a $200 million advance, but it also marked a significant step up from their earlier, less significant projects with Sega. The Xbox was introduced in 2001, equipped with a custom-made chip from Nvidia called the NV2A. This venture not only enhanced Nvidia's financial status, but also solidified its position in the technology sector. The development and success of the NV2A chip laid the groundwork for Nvidia's booming business in the following years, leading them into more complex projects, such as crafting processors for Sony's PlayStation 3. One of Nvidia's strategic decisions was to identify itself as a fabless chip company, a term that might seem complicated, but really just means they design chips and let someone else handle the manufacturing. Huang, the leader of Nvidia, firmly believed this method was a smart way to cut down on costs. For the last 3 decades, Nvidia has relied on a partnership with the Taiwan Semiconductor Manufacturing Company, also known as Taiwan Semiconductor Manufacturing Company, which is a leader in the field of creating semiconductors. The advanced technology Taiwan Semiconductor Manufacturing Company uses to manufacture chips has played a key role in Nvidia's continued success. Huang himself has said that a big part of Nvidia's achievements can be traced back to the innovative work done by Taiwan Semiconductor Manufacturing Company. By focusing solely on the design aspect of chips and outsourcing the actual production, Nvidia could invest more resources into new ideas and projects. They went beyond their usual market of gaming chips and graphics, venturing into the broader possibilities of GPUs and their ability to process many tasks at once. As one success ended, new possibilities emerged. Revolutionizing parallel processing, Nvidia aimed to provide developers with the tools and software they needed to fully utilize the power of GPUs. In 2006, this led to the introduction of Compute Unified Device Architecture, a toolkit that made parallel computing much easier and more accessible. Prior to the advent of Compute Unified Device Architecture, the process of programming a GPU was viewed as a difficult and off-putting task for many developers, often involving complex and intimidating procedures. Before Compute Unified Device Architecture arrived, programmers often struggled with complex low-level machine languages and APIs, which usually caused frustration rather than solutions. Compute Unified Device Architecture, however, simplified everything by allowing the use of more straightforward programming languages such as C, C++, and Java to control GPU operations. This breakthrough fundamentally changed the approach to processing power and software development. The Compute Unified Device Architecture introduction had a significant and widespread effect. It wasn't just about better graphics. It enabled various industries overwhelmed with data to efficiently use the parallel processing capabilities of GPUs. The movement gained significant momentum in 2008, when the Tokyo Institute of Technology employed Compute Unified Device Architecture enhanced GPUs for their supercomputer, achieving impressive results. Following this, major companies like Amazon Web Services, Google Cloud Platform, and Netflix started using GPUs to improve operations across cloud computing, machine learning, video streaming, and complex web searches. The biggest shift occurred with the rise of artificial intelligence in 2012. An important development was the creation of AlexNet, an advanced deep learning neural network developed by Alex Krzyzewski, a PhD student at the University of Toronto. AlexNet utilized the full potential of GPUs to greatly improve the performance of neural networks. This set a new benchmark in the field and spurred a rapid increase in AI research and applications. This transformation showed that the proper technological tools could dramatically change the capabilities of data processing and problem solving. Someone decided to connect two Nvidia GeForce GTX 580 gaming graphics cards to a standard computer. Alex Krzyzewski was using these cards to train the AlexNet neural network with a huge set of 1.2 million images. The results were quite impressive, as they showed a significant decrease in errors in image recognition, down to 15% from the previous year's 25%. Although these figures might not seem extraordinary today, at that time, they represented a significant advancement. They paved the way for the powerful AI tools we now use without much thought, such as ChatGPT, Google Gemini, and Google Lens, which demonstrate far greater precision. This achievement signaled the end of a long period of doubt in AI technology, known as the AI winter. For many years, numerous experts doubted the practical usefulness of neural networks, dismissing them as impractical, until they were proven wrong by this experiment. The Nvidia GeForce GTX 580 cards were crucial to this shift in perspective because they were tailored for compute unified device architecture, which allowed them to efficiently run multiple processes at once. This capability was not just a minor improvement, it was crucial for advancing AI technology at the time. Deep learning technologies, like those used in AlexNet, suddenly captured everyone's interest. Nvidia, having invested early in compute unified device architecture and its software ecosystem, emerged as a leader in this area. This strategic move paid off massively. Nvidia's graphics processing units quickly became essential for developing and launching advanced AI and language models. A prime example is OpenAI, known for its ChatGPT model, which used Nvidia's A100 series GPUs to rapidly release their AI models into the market. With the launch of ChatGPT in November 2022, a rush ensued among large tech companies to secure Nvidia's GPUs. The A100 models, in particular, were highly sought after. Microsoft acquired a remarkable 10,000 of these units. Each GPU carried a price of $110,000, yet Nvidia managed to sell hundreds of thousands of them, indicating a massive surge in demand. This surge wasn't merely a chance occurrence. It was a result of Nvidia's deliberate efforts in marketing and positioning their products to meet the increasing demands of the technology market. Consequently, Nvidia's sales skyrocketed, reaching an impressive $13.5 billion in the quarter ending July 2023. This success was not just about profits. It demonstrated the overwhelming demand in the tech sector for powerful computing capabilities and Nvidia's strategic foresight in fulfilling this demand. Nvidia experienced a series of financial triumphs that caught the attention of the world. On May 25th, the company's stock market value increased dramatically, marking a 101% rise from the previous year and reaching a staggering $184 billion in just one day. These achievements placed Nvidia in an exclusive realm of corporate giants. However, this remarkable rise in market value prompted some to question the durability and genuine worth of such a high valuation. As the company's market cap later hovered just over $2, it became crucial to dissect the factors contributing to such valuation. Observers began to ponder the extent to which Nvidia's valuation was propelled by actual technological innovations versus market excitement and investor speculation. This situation required a thoughtful examination of Nvidia's technological advancements. It was necessary to determine whether these innovations genuinely addressed pressing challenges or were simply impressive technological feats aimed at capturing market interest. Such scrutiny was essential to understand whether Nvidia's advancements would have a significant and lasting impact on technology and everyday applications. Questions arose about whether these technological advancements were transformative breakthroughs that would redefine the industry or merely temporary spectacles. The rapid increase in market value could be perceived as a potential bubble, perhaps inflated by short-term market dynamics rather than robust, enduring technological progress. Observers and analysts were encouraged to adopt a critical perspective, delving beyond the superficial allure of high financial numbers to assess Nvidia's technological innovations, practical implications, and durability. The challenge was to evaluate the real-world applicability and sustainability of these technologies, beyond the dazzle of market statistics. Is Nvidia's soaring market value a bubble waiting to burst? Share your thoughts in the comments below. And don't forget to like, subscribe, and stay tuned for more insights.